All right, let's get started, guys. So I'm going to go over some homework problems. It's not going to be really long. It's going to only have 4 problems. So the first one is number 2 on the homework: 7 over x plus 8 plus 7 all over x squared minus 64. So the first thing you should always do is factor everything out. So we have 7 over x plus 8 plus 7 x squared minus 64. It's x minus 8 times x plus 8. All right, so the first thing you should always do is factor everything out. And then you need to make sure they have the same denominator so you can actually add them. So this first fraction is missing an x minus 8 in the denominator. So you multiply top and bottom with that x minus 8. And what you end up getting is 7x minus 56 all over x minus 8, x plus 8. That's fine. All plus, the second one isn't missing anything. That's what you get. And then since now the denominators are the same, go ahead and add like term or add the tops. You have 7x minus 56 plus 7. That gives you 49. All over x minus 8, x plus 8. You could factor out the top if you wanted to. Doesn't really matter because it's not going to cancel out. But once you get to this part, and honestly, before you start canceling anything out, what I would do is list out your restrictions. So here, x cannot equal 8 or negative 8 because those x values would break the whole function, and you end up dividing by 0, and that doesn't make any sense. So in this case, my answer is 7x minus 49 all over x minus 8, x plus 8, when x cannot equal 8 or negative 8. Are we okay here? Go ahead. You could factor out a 7 if you really wanted to. And you just get 7 times x minus 7 all over x minus 8, x plus 8. It's just that I didn't bother with it because it wouldn't cancel anything out. So it doesn't really matter too much. I don't know. I can only talk for myself. Like I personally wouldn't care too much, but just stay safe and say, yeah, it's factored out. So we're just going to say, yeah, factor it out to be safe. Do 7 times x minus 7 all over x minus 8, x plus 8. And that's, I guess, the real final answer. Any questions about that? We good? All right, number 2. We have 7 minus 6x squared minus 9x minus 42 all over x squared plus 2x. So first thing I'm going to do is I'm going to factor everything out. So 7 is just going to stay a 7. On the top, I can factor out a 3. And I'm left with 2x squared minus 3x minus 14. On the bottom, I can factor out an x and be left with x plus 2. And then 2x squared minus 3x minus 14. If I want to factor that out, I'll do on the side. So I'm going to do my slide and divide method. I'm not sure if you know how to do that if you're not my student. But if you don't know how to do it however you want. Slide it over, factors of negative 28. To add up to negative 3. That's negative 7 and 4. So x minus 7, x plus 4, all over 2. So what that ends up factoring to is 2x minus 7 times x plus 2. And that's all over x times x plus 2. So first thing you should always do is factor everything out. And this is what you should get when you factor everything out. So from here, I want to combine these two. So to combine them, I need them to have the same denominator. So that means the 7 on the left side by itself is missing an x and an x plus 2 on the bottom. So I'm going to multiply the 7 with both those terms, x and x plus 2. So you have 7 times x plus 2 all over x times x plus 2 minus 3 times 2x minus 7 times x plus 2 all over x times x plus 2. Right, factor everything out. Make sure they have the same denominator, because only when they have the same denominator can you subtract or add fractions or rational expressions, whatever you want to call them. And then from here, you want to expand everything out. So what I have is 7x times x plus 2, which would give me 7x squared plus 14x minus this right side. Well, actually, you could have simplified this up from the very beginning, couldn't I? We're going to back up a bit. So you could have solved it that way. It would have been a lot harder. If we go back to this part right here, sorry about that. If you factor out the top, what you see is that the x plus 2's right here cancel out. But honestly, before you cancel out anything, what I would always do is list out your restrictions to make sure you don't forget about it. So you factor everything out. X cannot equal 0 because of x, or negative 2 because of x plus 2. So we backed up a bit because you could have reduced it from the beginning and made it a lot easier. So before I cancel anything out, I'm going to list out my restrictions. X cannot equal 0 or negative 2. And then after that, I'm going to go ahead and cancel this out. Makes it a lot easier to work with in a bit. All right, everyone with me? Are we okay? So from here, I want to make sure that they have the same denominator. My denominator now is a lot simpler, it's a lot easier to work with. So the 7, I'm going to multiply top and bottom by x. So they have the same denominator, so I can add them together. You get 7x all over x minus 3 times 2x minus 7, which I'm going to expand out. Get 6x minus 21 all over x. Which is just 7x minus all of 6x minus 21 all over x, which would then give me 7x minus 6x plus 21 all over x, right? Distribute this negative in. And then finally, we get x plus 21 all over x. That's only true when x doesn't equal 0, or was it positive 2? Negative 2. And that's your answer. So one of the biggest tips I can give is always list out your restrictions before you cancel anything out. There's a lot of people, when they're doing these problems, they get to the very end, they see, oh, well, my x can only not equal 0, is that very end part, and they forget about the negative 2 that happened before. So I always say, before you cancel anything out, list out your restrictions, and that's going to give you, all your restrictions, and it makes it so you don't forget about anything. Any questions about that one? Are we okay? All right, now we have a more complicated one. So we have a division and a multiplication all in one. So for these, what you want to do is you always want to factor everything out first. So it's a lot of work. It looks pretty big, but it's pretty much the same thing as before. Factor it all out, and then start canceling stuff out that you can. So this first part, 2t squared plus t minus 6. If I want to factor that out, so factors of negative 12 that add up to 1 is 4 and negative 3. Divide these by 2. And the first part is going to factor out to 2x plus 2. Sorry, x plus 2. And 2x minus 3. That's the first part right here. Underneath it, you can factor out a 2, and you're left with t minus 3. Then we'll go into the second fraction. I have 3t squared plus 7t minus 6. So I'm going to go ahead and factor this part right here. So factor however you want. Factors of negative 18 to add up to 7. That's go ahead. Non-negative. Non-negative, right. Non-negative, thank you. X plus 9, x minus 2, divided by 3. And we get x plus 3 times 3x minus 2. On the bottom, I can factor out a 6. But go to that bottom part right here. I'll do on the side, I can factor out a 6, and I'm left with t squared minus 2t minus 3, which is going to factor out to t minus 3, t plus 1. So 6, t minus 3, t plus 1. Is everyone with me so far? Are we good? All right, so I'm going to erase some of this so I have more room to work with. We're going to go to the third one. Can I erase this or anyone still copying? Good. All right. So this last part, we're at 3t squared plus 4t minus 4. We need factors of negative 12 to add up to 4. That's going to be 6 and negative 2. X minus 6. X plus 2 divided by 3. And you get that factors to x minus 2. And 3x plus 2. I keep switching between x's and t's. I'm going to change them all back into t's and as you forget. Oh, the way I factor is if I have 3t squared plus 4t minus 4, is I do something called slide and divide. I'll take this 3, kind of slide it over. So I have t squared plus 4t minus 12. So I'm going to factor this part out right here. So I have t squared plus 4t minus 12, that factors to t minus 6 and t plus 2, right? But because I slid that 3 over, I have to put these both over 3. So 6 over 3, that reduces to 2, right? That gives me the t minus 2 to x minus 2. And then this doesn't reduce. So if it doesn't reduce, it goes to the front. So just how I like to factor however you want, is another way to factor. Oh yeah, it's not the same. Wow. You're right. So plus 2, thank you. Is positive 4, yeah. 6 and negative 2, sorry about that, yeah. Are we good? Any questions? Good? Great. Let's go on to that last part. So same thing, factors of negative 18, to add up to 3, that's going to be 6 and negative 3. So t plus 6, t minus 3. Put those over 2, and you get t plus 3 and 2t minus 3. That's the most painful part, factoring it all. I'm going to change all these x's to t's, so I kept forgetting about them. But they are all t's. So factor everything out. And honestly, this is the part where I would list out my restrictions. Before I mess with anything else, if everything's factored, I'm going to list out my restrictions from here. Because when you do, it makes sure that you don't forget about anything. And remember your restrictions, where they're going to come from, are going to be all the denominators, but also the numerator of the fraction that's after the division sign. Right? If you're dividing by a fraction, you flip that second fraction. So if this is division, I'm also going to have restrictions from the top part of that. Right? This fraction is going to end up being flipped. So that t plus 3, 3t minus 2 is also going to give me a restriction. So from here, I'm going to list out my restrictions. T minus 3, that tells me that t cannot equal 3. T minus 3 tells me 3 as well, but I already have that. T plus 1 tells me negative 1. T plus 3 tells me negative 3. 3t minus 2 tells me a positive 2/3. T plus 3 gives me negative 3, which I already have. 2t minus 3 is 3 over 2. T plus 2 is negative 2 and 2/3. All right. So these are all my restrictions. Go ahead. Yeah. Because when you flip it and you simplify everything down, you're right. Like the final answer, this t plus 3 or the t minus 3t plus 1, it won't be on the denominator anymore, and it wouldn't break the function at that very end. But the point of this problem is that we want to solve this whole thing right here, right? I want to solve this out. So your restrictions is anything that'll break the function or the expression at any part throughout the problem. So anytime solving out this expression, if it'll break the function, make it undefined, that has to be a restriction, because if it's undefined in the middle, it can't magically become a defined function. Once it's undefined, it's undefined. You can't do it. Does that make sense? So anything that'll break at any point, it has to be a restriction. All right, so these are all my restrictions. And now that I have them restricted, now I'm going to start, I'm going to flip the division sign or the fraction after division and start canceling stuff out. So I'm going to rewrite it one more time. I have t plus 2, 2t minus 3, all over 4 times t minus 3. And that division is not going to be a multiplication, and I'm going to flip it. I have 6 times t minus 3, t plus 1, all over t plus 3, and 3t minus 2, multiplied by t plus 2, 3t minus 2, all over t plus 3.
Now 3 o'clock. If you are not with a coach, director, sponsor, or in tutorials with a teacher, you must now exit the building.
So I rewrote everything, but I flipped that second fraction. But this one right here, because anytime you're dividing by fractions, you always flip the second number, right? Like if I have something like 1/2 divided by, let's say, 3/4, to solve this out, you say, well, this is 1/2 times 4/3, right? You get that, right? Well, these expressions, they're just really complicated fractions. The same rules apply. So that's why here, you always flip the second one, not the first one. Because it's this fraction divided by this fraction. So you always flip the second one and the one after, that's what's divided. Does that answer your question? All right, so let's go ahead and cancel stuff out. So these t minus 3's cancel out. This 2t minus 3 and this 2t minus 3 cancels out. 3t minus 2's cancel out. Am I missing anything? Sure I am. That's everything, right? So 6 parts you reduce that in a bit. We can do that too. So that becomes 2 and 3. If there's any factors that cancel, is that it? That's it. All right, so what you end up getting at the end is t plus 2, well, 3 times t plus 2 times t plus 1 times t plus 2, all over 2 times t plus 3 and another t plus 3. And that's going to be your answer. And this is your answer with your restrictions, right? This is the answer with these restrictions. Both parts are important. So make sure you put both of them. So your answer is this whole thing when your t does not equal these numbers.
Could you simplify t plus 2?
The t plus 2 in the bottom, you mean? Or the top and bottom? You could. Yeah, you can do that if you want to. It doesn't. Any questions about that? Are we good? Ready to keep going? So you want to start copying? Good. All right, let's keep going. So now this complicated 137. I'm going to show you guys, if you're not my student, you probably didn't see this way, but I'm going to show you a different way to solve it. I think it's a lot easier. Well, maybe not easier, but it makes it more clear how to solve it. So what I'm going to do when I have a problem like this, and it's how I like to solve it too. When I did the quiz, it's how I solved it. What I'm going to do is I'm going to kind of break it apart and put the top divided by the bottom. So I have this top part, which is 4 over x squared y squared plus 4 over x y cubed. Right, that's the top part. And that top part is getting divided by 2 over x cubed y squared minus 2 over xy to the 4th. So this expression right here is the exact same thing as what we started with the problem, the exact same thing. I I just prefer it horizontally rather than stacked on top of each other. I think it makes it a little more clear. And instead of multiplying everything with the LCD, like y'all saw in the notes, what I like to do instead is I'm going to solve out each parenthesis by itself and then divide everything at the end. In my opinion, it just makes it a little more clear. You know what's happening and why stuff are happening. You don't get stuff mixed up, and I think it helps you get your restrictions a lot easier as well. So from here, I need to add these two fractions inside the parentheses. So 4 over x squared y squared plus 4 over x y cubed. So to get them to have the same denominator, what I'm going to get is 4y over x squared y cubed, right? Because this first fraction is missing a y in the bottom. All plus the second fraction, the 4 over x y cubed, is missing an x in the bottom. So we get 4x all over x squared y cubed. That's all going to be divided by the second fraction I'm about to solve out. So same thing, I need these to have the same denominator. So in the first one, if I compare the two, the two denominators, the first one's missing a y squared, and the second one is missing an x squared. And then I can add like terms. Right now they have the same denominators, so I can add them. So in the first one, what you get is 4y plus 4x all over x squared y cubed divided by the second one. When you add it, you get 2y squared minus 2x squared all over x cubed y to the 4th. Everyone with me so far? You don't need these. So from here, before I cancel anything out or before I flip anything, I'm going to go ahead and figure out, what are my restrictions. Remember, it comes from the denominator, but also if you have a division, the numerator after the division sign. So what this tells me is that x cannot equal 0, and y also cannot equal 0 because of these x squared y cubed or the x cubed y to the 4th. Then at the same time, I have this 2y squared minus 2x squared, which we could factor out actually if we will right now. So that part right here, you can factor out a 2 and get y squared minus x squared, or y minus x, y plus x. It factors out, so I'm going to go ahead and rewrite this actually. Sorry about that.
Can we factor out the other one?
Which one? The 4 here? Yeah. You could. I just haven't gotten to it yet because it doesn't really matter. We'll get there in a bit. All right, so I'll just factor everything out first. I keep forgetting to do that. But anyway, it factors out to that. So what that tells me about my restriction, which is the important part, is that y cannot equal x or negative x. Right? These two factors right here tell me that y cannot equal x or negative x. Are we good? Make sense? Good. You could write x cannot equal y or negative y. It's fine. But it's more just once you have one of these expressions, like as soon as you have y equals x or negative x, you don't need to write its opposite because it's implied in there. Y can't equal x. Well, that means x can't equal y. Y cannot equal negative x. Well, x can't equal negative y. It's already implied in there, so you don't need to write it. All right. So these are my restrictions. You have a question? No, I don't know why I did that. You can write it like this if you want to. So it doesn't really matter as long as what you're saying is correct. There's a lot of different ways to write it. So you can write it all in one if you want to. It doesn't really matter. All right. So from here, let's go ahead and rewrite it so we can solve it out. The 4y plus 4x, it does factor. I can factor out a 4 and get y plus x on the bottom, x squared y cubed. I'm going to flip that second fraction to get x cubed y to the 4th all over 2 times y minus x, y plus x. So I got my restrictions. Now I'm free to cancel whatever I want out because I'm not going to forget about anything. Anything that could be a restriction, I've listed it. So I'm going to start canceling stuff out. These y plus x's cancel out. this will reduce down to a 2. This x squared completely goes away and the y squared as well. And all you're left with is an x and y on top. So what you end up getting is 2xy all over y minus x, with x cannot equal 0 and y cannot equal 0 or plus or minus x. Does that make sense? Any questions about that? All right. If not, that's all I have. That's pretty much everything we went over.